Okay, so this is going to be practice over oxidation numbers, and on the back we're going to do some more practice with a lot of things, but half reactions. And so this was one of the sheets that I gave you in class. So here we go. So when we do oxidation numbers, there's a few things we got to remember. That there are some exceptions to what we believe to be oxidation numbers, right? So we learned about looking at the Redox structure, looking at your periodic table, but there are a lot of exceptions. Now, in class, I made it maybe sound more dramatic than it actually is, because a lot of our exceptions come from our non-metals, okay? So in this area over here, so anytime you're trying to find one of these in this area, you need to remember that we need to do possibly some calculations to find that, okay? So there are a couple of rules that you need to remember, okay? The first rule is all compounds have an overall charge of 0. Okay, every compound will have an overall charge of 0. The second one is that any alone elements alone will have an overall charge of 0. Okay, and the third one that I mentioned in class, and we talked about in class, but I don't know if we ever actually wrote it down, was use the given charge, if possible. And we'll talk about that, if possible. Use the given if possible. If I give you a charge, you need to use it, okay? Now, this is kind of our top set of rules here, okay? And then our second set is about individuals. So, if hydrogen is in a compound, it will almost always be +1. There are some exceptions to that, though. That's why they're in our second set of rules. Oxygen will almost always be -2, and the exception here is in peroxides, and there's an example on here, so I want to put that down here where it's going to be a -1 if it's in a peroxide, but a lot of our examples you're going to think of it as -2. Okay, fluorine will almost always be -1, and I think that's about the only three that we're going to be using. Okay, so look at these and then look at those. All right, so a few quick examples, and if you notice down here is the answer key, but a little explanation. Chlorine's by itself, so it's going to be 0. Chlorine, I give you that negative there, okay? If you can't see it in the video, on your paper there's a negative there, so this has got to be -1 because it follows rule number 3 right here. Sodium's by itself, which is rule 1, and so that should be a 0. And then I give you a sodium +1. Well, that follows rule 3 here. So it's going to be a +1. All right, and that's how we go all the way down until we get to our first one, number 8. Right. So the rule is hydrogen's always a +1, and oxygen's a -2. Okay, and so H2O overall should equal 0. And we have when we look at overall charge, we need to look at how many there are of each as well. Okay, so since there are 2 hydrogens, that's going to be a total of +2, -2, because there's 1 oxygen, will give you 0. Okay, let's go to a little bit harder one like this one. This is chromate, and notice how they give me a -2 here as an overall charge. Well, instead of setting it equal to 0 like I would do for this one and this one, I'm going to set it equal to 0 because they give me the overall charge. So now, oxygen, if I set, let's do it down here a little bit, you can see. So, -2 is going to be my overall charge. I'm not sure what chromate is, but I know that there's 2 of them. And I know that oxygen is going to be a -2, so when I add that plus oxygen, which is a -2, and there are 7 of them, all of this needs to equal -2. So when I have 2 chromiums, if I kind of rewrite my equation here, 2 chromiums plus -14 has to equal -2. If I go to my next step, 2 chromium minus 14 equals -2, which means, what does chromium have to be? If I divide that by 2, divide that by 2, -14 equals, let's see here, So that's going to have to be a 6, right? If I put a 6 right here, if I put a 6 right there, okay, and that'll equal negative 12, or sorry, just positive 12, so this is going to be a positive 6. So if I put a positive 6 here, oxygen is minus 2. Notice how I'm just putting the charge of one of those oxygens, one of those chromates, okay? And that's how we do it all the way throughout. So if we get to, let's go to a little bit harder one of NH4Cl, okay, NH4Cl. So let's see here. I know that NH4 is my polyatomic ion, and if I look at my chart, I know that NH4 has an overall charge of +1. Why is that important? Because I don't really have a rule for chlorine. So I don't have a rule for nitrogen, I don't really have a rule for chlorine, but I do have a rule for hydrogen. And if I see that this is a polyatomic ion, I look at my polyatomic ion chart here, and I see that ammonium has a +1 charge, which means all of this right here has to equal +1, right? So if I say nitrogen plus 4 hydrogens, each of them have a +1 charge, has to equal +1, right? Well, N plus 4 has to equal +1, so what does N have to equal? -3. So if I come back down here, N is a -3, H is a +1. What does chlorine have to be? Well, this is easy right here because +1 plus what has to equal with an overall charge of 0? Oh, that's got to be a -1. No, there we go. Sorry. All right, and so there's my answers for each one of those. Okay, the one in here that I was talking about with the exception here was where did it go? Number 23, H2O2. Okay, this is what we call a peroxide, and so we have. Why do we call it that? Because we have 1 hydrogen per oxygen. That's why it's 2 to 2. Hydrogen peroxide. So every hydrogen has 1 oxygen with it. Well, if I follow the rules here, if I put in a -2 on oxygen, that means it's not going to come out to be 0, which is why we change it to -1 when we have hydrogen peroxide. So hydrogen keeps its rule, and then oxygen goes to -1. But you will not have any of these peroxides on your quiz or test. So I would stick with some of the other examples. On the back, here is just following some more of those rules without an answer key. And a little side note as well, since this is ionic, we can just uncross those charges to figure it out. So that's going to be a 3, and that's going to be a 2. Cadmium and nickel, uncross the charges. Right, cadmium is going to be +2, and make sure you put pluses and minuses here. Okay, nickel's or nitrogen is going to be a -3. Right, the only time like this is not ionic, so that means you're going to have to find the charge for nitrogen. Okay, so to do that, we would have to set the overall charge equal to 0. So if I set the overall charge equal to 0, nitrogen doesn't have a rule, and there's 1 of them. Plus hydrogen is a +1, and there are 3 of them. So N plus 3 has to equal 0. Right? So this is going to be a +1. What does N have to be? A -3. Okay. Remember, anytime you have anything by itself, an A, F, C, I, J, those are all going to be zeros, okay, because they're by themselves. Now, down here on this section, we added quite a bit of things that you should be able to do, and really this is one of the best reviews if you can do all of this stuff. So to kind of list out those rules, or not rules, but directions that you should be able to do for each one of these. So you should be able to identify, and I'm going to kind of put these in the order that they should be done as well. Okay, so you should be able to tell me what type of reaction each one of these are. B, you should tell me if they can be completed. Completed. did. What do I mean by that? Well, you're looking for single and double replacements. Single replacement and double replacements. Because if you find one of those, you should be using your activity series and solubility table. Okay? Then if it can be completed, you need to balance it. Alright? After you balance it, you should be able to write it in word form, which means taking all of these formulas and putting them into a word form, also using solubility signs. And we're going to do an example. We did it in class. That's spelled wrong. Solubility. There we go. The solubility signs. So that's talking about all of these things in the parentheses that you see in the equation, right? And then E, word form, and then you should be able to tell me, is it redox? And remember, if it's redox, redox is anything but double replacement and neutralization, right? So when you go to identify, if it's anything but those two, it will be redox. If it is those two, it will not be. And if it's redox, we should be able to find what is being oxidized and what's being reduced. And then the last step, if you find those, and if it's this, then you should find those, and then you should also be able to write the half reactions for each. Okay? And so you will be tested on every single part of this at different times throughout your quiz and test. You need to be prepared to do all of these to do well. Okay? So let's practice one of those on this. We did, in class, we did C and D. Okay, so you should be able to find the video over, I believe it's day 5. Day 5 lesson. And so we did those. Let's go down and do F. We got some space here. So we start off with identify. Well, I have an AB plus a C. Well, a compound plus an element, that's going to be single replacement. Right? And let me put single replacement out here. Because it's single replacement, I need to, well, look, single replacement, I need to see if it goes to completion. Right? And so I need to go over here, because it's single replacement, I need to be using my activity series. So I need to look to see, will magnesium, right, this is the loner that wants to have some friends. Here are the friends, right? The loner wants to have friends. So this guy looks to bump out the other one that's just like him. So this is a metal, aluminum's a metal. Will magnesium be powerful enough to bump out aluminum? Well, I go here, magnesium wants to bump out aluminum. They're very close, but magnesium is still higher, so it will work. Magnesium is active enough to bump out aluminum. So this reaction will work. That means I should, if I don't give you the products, you need to show that reaction happening and write it over here. Okay, now I should be able to balance it, and when I do that, I can start with chlorines, because there is a 2 and 3. We need to balance that as, get that to 6. So if I put a 3 there and a 2 there, my chlorines are balanced. Now I can go to my aluminums, put a 2 there, my magnesiums, put a 3 there, and it should be balanced. Okay? Then I need to put it into word form. So that means I need to be able to write out the word form of this formula, and then write all of these solubility signs at the bottom, or right next to it. So this should be, yeah, we can do it here. Aluminum chloride, and actually, I've already messed up. This should be aqueous, because of that. So it should be aqueous aluminum chloride plus solid, not solid, magnesium yields solid aluminum plus magnesium chloride, aqueous magnesium chloride. Aqueous magnesium chloride. Okay, there we go. So I wrote all of that in word form using those signs. Notice how I didn't do anything with the coefficients. Coefficients are not represented in the word form. Okay, the next one, determine if it's redox. Right? Well, anything but double replacement. Okay, so this is single replacement, so yes, this will be redox. So if it's redox, I should be able to determine what's oxidized and what's reduced. Okay, so before that, now I need to go back up into this equation. So I'm going to do my redox in red so you can maybe see it a little better. So now I need to do oxidation numbers all the way for each element, which is where this comes into play. Practicing this comes into play. So I know that aluminum chloride, well, this is ionic, so I can just bring that +3 and then a -1 there. Magnesium's by itself, 0. Aluminum's by itself, 0. Magnesium chloride, once again, it is ionic, so I can just uncross my charges. +2, -1. All right, and then I need to look here, because if I look at chlorine, chlorine stays the same. In redox, we look to see what's happening to electrons. Well, nothing happened to the charge of chlorine, so that means chlorine's electrons didn't do anything. They stayed the same. But if I look at aluminum, aluminum went from a +3 to a 0. Well, how did it do that? That means it gained 3 electrons because it became more positive. Electrons are negative, so if it goes from a +3, +3 -3 gets you to 0. Okay, so that means it gained, well, if I remember oil rig, that G is in rig, reduction is gaining. That must mean hydrogen is being reduced. Okay, then if I look at magnesium, magnesium goes from 0 to +2. So how do we go from 0 to +2? That means we lost 2 electrons. Well, how does that work? Well, 0 minus negative, there's your double negative, gets you to 2, right? So a double negative makes a positive, so 0 technically, 0 minus gets you a positive, +2 gives you to 2. So that must be what's being oxidized, because oil oxidation is losing. So magnesium is being oxidized. So that was step F. Now we go to G, writing your half reaction. So if we start with our reduction, let's see, there we go. Hydrogen starts off as, not hydrogen, I'm sorry, aluminum. That should be aluminum there. Aluminum starts off as +3 and ends as aluminum 0. How did that happen? Well, it gained 3 electrons. So it gained 3 electrons to produce that. And there's your half reaction. There we go. Magnesium starts off as 0 and it ends as +2. Right? How did it do that? Well, it lost 2 electrons. The problem is we can't say -2 electrons because we can't put a minus in a chemical reaction. So we have to say magnesium 0 produces 2 electrons plus magnesium +2. And there's the rest of your half reaction. Okay? And that's our last step. Okay? So I hope this video helped.